Wonderful. This is the second part in the fuels and ethanol production video. In the first one we looked at complete and incomplete combustion, and now we're going to look at a method for producing ethanol. So we're just going to go through a couple of slides. Here we go. Right, now there are actually two methods of producing ethanol which are on the IGCSE syllabus. But we're only going to look at one of them, and that method is producing ethanol by fermentation. And so what I've got here is a diagram which shows the kind of kit you need to do fermentation in the laboratory. So here is our mixture, which is busily fermenting away, and what we've got in here is we've got a load of water, and into the water we've dissolved sugar, normal sugar, and we've mixed that with a little bit of yeast. Now what happens is that the glucose within the sugar, now glucose has a formula of C6H12O6, and that's dissolved in the water, anaerobically breaks down. Now anaerobic means without oxygen, and so we have a decomposition and we produce ethanol. Now I wonder if you can remember what the formula of ethanol is. Now I usually use the formula C2H5OH, and that is also dissolved in water, and it also produces another chemical. It produces carbon dioxide, so CO2 gas. Now if you look at this equation you'll see that it's not balanced. You'll see that we've got 6 hydrogens over here and we've only got 3 over here. You'll see we've got 6 hydrogens here, 12 over here. So as there are hydrogens in the ethanol and in the sugar, the glucose, let's try and balance the hydrogens first by putting a 2 here. So that sorts out the hydrogens, and it also means that we've now got 4 carbons over here. So let's balance those with 2 carbons there, and let's just check we've got the right amount of oxygen. So we've got 2 oxygens here and 2 lots of 2 here, that's 4, so 4 plus 2 is 6. Brilliant, we've got 6 there. So this is the equation for fermentation. We're forming 2 lots of ethanol and 2 lots of CO2. And the carbon dioxide bubbles out of this mixture, and the bottle is fitted with a very special cap. It allows gases to escape, but it doesn't allow gases to go in. Gases cannot enter the vessel. There's a liquid trap in here. In actual fact, the person who drew this diagram has put lime water rather cleverly in the liquid trap. So as carbon dioxide is coming out through the lime water will form a white precipitate, or you might say cloudy. Now it's essential that you learn the raw materials needed for fermentation, and the raw materials are sugar, water and yeast. And you might be thinking at this point, well, what on earth is the yeast doing? Well, the yeast contains an enzyme called zymase, and the zymase catalyses the breakdown of the glucose. So this process wouldn't happen without the yeast, or it would happen but just incredibly slowly. Now the fact that yeast is in our mixture really does determine the kind of conditions that we can do fermentation at. We do it at roughly 35 degrees Celsius. Somewhere between 30 and 40 degrees C is fine. And the reason we do it at this warmish temperature is that this is a higher temperature than room temperature, which means the reaction proceeds quicker than it would do at room temperature. Now that's a good thing. We're going to form ethanol at a faster rate than we would do if we just left this lying around in the house. But we can't go any hotter really than 35 or 40 degrees C. If it goes any hotter, unfortunately, the enzymes within the yeast, the zymase, starts to denature. And that means it can't work, which means the process, or the speed of the process, is effectively zero. So we keep it at that temperature to ensure it goes slightly quicker than it would do at room temperature, but not so hot that the enzymes are denatured. Now, unfortunately, it would be wonderful if, I'll start that sentence again, it would be wonderful if all the sugar within this mixture could be converted to ethanol. But unfortunately, when this mixture reaches 15% ethanol content, the process stops. So we can only produce 15% ethanol yields from this process, which is a bit of a pain really. And the reason for that is because once you get to 15%, the ethanol starts to kill the enzymes within the yeast. And I use the word kill rather lightly. It probably does something rather complicated, which I'm not going to go into here. But we don't want a sugary, watery mixture all mixed up with our ethanol. We want pure ethanol from this process, so we have to extract the ethanol from this sugary mixture. So we have to use distillation. So ethanol is removed from the mixture by distillation. Or you might even use fractional distillation. Now that's a bit of a pain, okay, but is one of those things. And that's an extraction process you should know about distillation. Now in the next slide I'm going to look at why fermentation is such a great way of making ethanol. So here we've got the pros and the cons of fermentation. Now the pros, what a big pro, is it uses sugar. So it uses sugar, which is a renewable resource. We can grow it very, very easily. I say very easily, but it's a lot more easy, well, it's a lot easier, should I say, to produce sugar than it is to produce crude oil from scratch. Now, crude oil is a source of a number of fuels, and actually, the other process of producing ethanol, you remember I said there were two processes, the other process involves using crude oil. So the fact that we're using sugar, which we can grow, and it's a renewable resource, is a real plus point for fermentation. Unfortunately, sugar requires quite a lot of land. If we're going to produce a lot of ethanol using sugar, we're going to need a huge amount of land to do it. So a con of this process would be that it uses a large amount of land. Now this land could be used for other things. It could be used for housing. It could be used, it may have been in Brazil, it may previously have been a rainforest, and now there's sugarcane growing on it. So that's a very, very reasonable very reasonable minus point in the box of fermentation. It also only produces 15% ethanol. And that's a very valid con when you compare it later in your chemistry course to the other process of producing ethanol. So only 15% ethanol is produced, and then you need to distill it. And it's referred to as a batch process. And the fact the phrase batch process doesn't often get used, but that means that you start a process and then it stops. It doesn't run continuously. And so this method of producing ethanol is a batch process, which is less efficient than a continuous process. Now, the fact it uses sugar is a real plus point. Not only is it a renewable resource, but it means that no crude oil is required. crude oil is a non-renewable resource, and certain countries don't have access to crude oil. So certain countries that might have access to sugar but don't have access to crude oil can produce ethanol by fermentation. Exam questions often ask you to weigh up the pros and cons of putting a fermentation plant in a particular country. So they might nominate a country which has a large amount of land. They might say, well, why is this a suitable country for putting a fermentation plant in? Or they might nominate a country which has an entirely unsuitable climate for growing sugar. So, for example, countries in the Middle East, it's not going to be overly easy to grow sugar out there, but they will have, those countries do have a ready supply of crude oil. So this is a little bit of a geographical issue, and something you might like to put your sort of geography heads on when considering these factors. I hope this video has proved useful, and hopefully I might make a few more. All right.